Good morning. We're going to spend a little bit of time today going over a math review, just to bring to a conclusion some of the important areas that we've covered in sixth grade. And then we're going to take a little sneak preview um, later on in the week with some of the areas or some of the concepts that you'll be looking at in seventh grade. So let's start with a word problem. And Julian is able to run a mile in 5 3/10 minutes. The school record for the mile is 8 2/10 minutes. What is the difference between the school record and Julian's record? What I want you to talk briefly about with the person next to you is what are the key words and how you will find your answer. Take out binder paper, and all the work that you're going to be doing this morning, you're going to do on binder paper, and that will be collected and turned in, and that will be your credit for today's class. So quickly take out what you need, and then discuss what are the key words and how you will find your answer. So I'm going to give you 3 minutes, and that's to take out the paper, put your name at the top, and then discuss and come up with the answer for this problem. So pause the video here, and you're going to come back in 3 minutes to share out your findings. Okay, pause and solve the first one. Okay. So the important information we have here is Julian can run in 5 3/10 minutes for the mile, and the school record is 8 2/10 minutes. What is the difference? Well, difference is the key word that I'm sure you had discussed, and difference means you're going to be subtracting, and you're going to be subtracting 8 2/10 and 5 3/10. Okay, and looking at 2 subtract 3, well, you can't do that. So we're going to be borrowing from the 7, make that a 12, and 12 subtract 3, you would have a 9. Remember, you're going to bring your decimal point down. You now have, because you borrowed 1 from the 8, you now have 7 subtract 5, and that answer is 2. And that 2 and 9/10 is the difference between the school record and Julian's record. Okay, so he can run 2 9/10 miles. Or he can run the mile, I should say, in 2 9/10 minutes, where the school record is 8 2/10. Okay. Now, rounding numbers. When you're going to be rounding a number, you're going to read the place value position, you're going to round to. You're going to write an X over that place value position, and you're going to underline the number to the right. If the underlined number is 5 or greater, the number with the X moves up 1. If the number to the right is less than 5, the number with the X stays the same. And we're going to apply that to these numbers here. Round to the nearest 10th place. Well, this is the 10th place, so I'm going to put an X over the 2 and underline the 6. I'm going to put an X over the 1 and underline the 2. And remember, what you're looking at is this is the place that you're rounding to. So when you look at the number to the right, if it's 5 or greater, this 2 is going to go up 1. When you're looking at the tenths place for this example, you have an x over the 1. You look to the number to the right, that's a 2. If it's 5 or greater, the 1 goes up 1. If it is less than 5, the number stays the same. And let's take a look at these here. We're going to set these up also. And then I'm going to give you 2 minutes to discuss these with your partner and write your answers on your paper. So right now, copy these two, set them up just like they're set up here. And I'm going to take a look at the next one. And we want the hundredths place. Tenths, hundredths. So I have an x over the 7, underline the 5. Tenths, hundredths, x over the 5, underline the 2. Okay? So you should have these copied on your binder paper, and under each example, you are going to write the rounded number. So take 2 minutes, discuss what you think your answers should be for these 4 examples. Okay, stop the video here and discuss, and then come back in and we'll check and see how you did. Okay, so you should have your answers decided for all of these. And again, we're rounding to the nearest 10th place. So the 6 is greater than 5. That means that 2 goes up 1. These other numbers drop off. You're only rounding to the 10th place. And let's take a look at this example. Remember, this is less than 5. So this stays 1. The rest of these numbers drop off. You're only going to the 10th place. In these next 2 examples, you're rounding to the hundredths place. So 7 is the hundredths place. 5 is the number to the right. And the 7 goes up 1 to an 8, and the rest of the numbers drop off. We have 5 in the hundredths place. The number to the right is a 2. So the 15 hundredths stays. The rest of your numbers drop off. Okay, here we go. Dividing by decimals. This is the success criteria we worked with this year. Rewrite in working form. This is your division statement. This is the working form. Write the decimal point in the quotient. So here is your decimal point. We're dividing by a whole number. So you write your decimal in the quotient and then you divide. I have 2,000 and I'm dividing it into 24 and 5/10. Well, I need to add a couple of more zeros. Otherwise, I'm not going to be able to continue. So I have 2,000. I'm going to look at 2,450. I'm not going to pay attention to the decimal point here. 2,000 is going to go into 2,450 one time and multiply back 2,000. Subtract okay. I want you to write down this much that I've already done here, and then I want you to continue the rest of the division. Okay? Give you about, I think, a minute to about a minute and a half should be enough to finish this. So pause the video here, and then in about a minute, check back in and see how you did. Okay, so I'm going to continue dividing by 2,000. 2,000 is going to go into 4,500 two times. Multiply back 4,000. I'm going to subtract, and I have 500. 500 is less than 2,000. I'm going to add another zero. I'm going to bring that zero down. 2,000 goes into 5,000 two times, and that's going to be 400 again. This time when I subtract, I have 1,000. 1,000 is less than 2,000, but I need to add another zero and bring this zero down. And now I have 2,000 into 10,000. Well, I'm going to just ignore all of these zeros here and these zeros here. And I'm going to look at 2 goes into 10 5 times. When I multiply back, I'm going to include these zeros. So I'm going to write these 3 zeros. 5 times 2 is 10. And you have your answer. Okay? And I have no doubt that's exactly what you got when you worked on the division problem as well. Okay? We spent a little bit of time this year in working with dividing decimals and the success criteria for dividing decimals. So, good job. Now, we have another word problem. Kayla works at a local restaurant. She needs to keep up with the orders for the pies for the next 16 weeks. That should be their best seller is apple pie. The restaurant uses 35 pies per week. How many pies does Kayla need to order for the next 16 weeks? So turn to your partner and have the discussion about what it is that you're looking to find and how do you think you would go about finding that. Okay? And you should have included in your discussion that the amount of time that the pies need to be ordered for is 16 weeks. And they use 35 pies per week. So there's a couple of ways that you could solve this, that you could work it out. You could add 35 16 times, or you could add 16 35 times, and that would get you the answer. But the most efficient way is to multiply 35 times 16. Okay, so on your paper, find out how many pies Kayla's going to need to order for the next 16 weeks. Okay, pause the video here and take about a minute and a half to do your multiplication and then check back in and see if your answer matches what I have here. Okay, so stop it here and check back in about a minute and a half. Okay, so I'm going to have 5 times 6 is 30. I'm going to carry the 3. 3 times 6 is 18, and 3 is going to be 21. Okay, I'm done with the 6. So I'm going to put 0 here as a placeholder. Now I'm multiplying by the tens place. And 1 times 5 is 5. 3 times 1 is 3. And when I add these up, 5 and 1 is 6. 3 plus 2 is 5. And 560 is the number of pies that Kayla is going to need to order, so that the restaurant has enough pies for the next 16 weeks. That's a lot of apple pie. Okay, on to the next one. So here's another word problem. This one is we're using fractions. And I'm going to have you, after I read through the problem here, talk with your partner about a strategy or some strategies that you could use to figure out how many cards, fractional amount of cards that Michael has left. So we know he has a collection of football trading cards. He gave 5/12 of his cards to his cousin Terry. He gave another 4/12 to his younger brother Warren. What is the fractional amount of cards? What fractional amount of cards does he have left? Well, the first thing I notice is it's not giving me any number of football cards. It's giving me fractional amounts. So that's going to be important when you discuss this. What strategy can you use to come up with the fractional amount of cards he has left? Okay, so take a minute, talk with your partner. What do you think you need to do? How would you solve this? And then we'll check back in. Okay, so pause here for a moment, for 1 minute, and then we'll check back in. Okay, well, I'm looking at 5/12 and 4/12. So this was taken out of the total collection that he has. And I know that if I add 5/12 and 4/12, it'll give me the total of cards that he's given away. And then how I can use that to come up with what he has left. Okay, my denominators are the same. 5 plus 4 is 9. So altogether, he's given away 9/12. What fractional amount of cards does he have left? So one of the ideas that you probably discussed is his full amount would have to be written as a fraction also. And if we took a look at his total card collection before he gave anything away, it would be 12/12. And he has given 9/12 of that away. And what you need to come up with is the fractional amount of cards he has left. My denominators are still the same. So 12 subtract 9 is going to give you 3/12. 3/12 is not lowest terms. I can reduce 3/12 by dividing numerator and denominator by 3. 3 goes into 3 one time. 3 goes into 12 4 times. So what fractional amount of cards does he have left? He has 1/4 of his original collection remaining. Question is he going to give any more away to anyone else? Okay, I want you to set up this grid on your binder paper. And then I want you to use the area model to multiply 3,451 by 612. So pause the video here and take about 3 minutes to multiply this out and to come up with your total. Okay, so pause it here, and then we'll check back in about 3 minutes. Okay, so now that you're finished multiplying, see if your products resemble what I have up over here. So take a moment and check and see if your answers match what I have here. Right. The next step is to add up all of your products that you have in each of the sections of the area model grid. And when you add them up, you should have 2,112,012. Okay, good job. Now, we have two regular division problems. These are not decimals, but you're still going to use the same steps that we used when we divided before. You're going to divide your divisor into your dividend. You're going to write your answer in the quotient. Then you're going to multiply back, subtract, and bring down. So copy these two problems on your binder paper and divide both of them. You can, if you have a remainder, you can write your remainder either as a fraction or as a decimal. That would be your choice. Okay, so take about 3 minutes, and let's give you 4 minutes, and complete both division problems. So pause the video here. Complete your division. You may work together if you would like. If you have a multiplication chart, please take it out and use it. And begin. Okay, so let's check back in and see how you did. Your quotient for the first division problem should be 167 and 30/45, or in lowest terms, 2/3. For your second division, if your quotient would be 119 and 76/82, excuse me, or in lowest terms, 19/21, or 19/21. Hopefully you did well with those two. I'm willing to bet that you did. But if not, then division is something that you definitely want to continue to practice, because this is going to continue to be an important skill for you in math. Okay, order of operations. Taking a look at what I have written here, and remembering when we do order of operations, we talk about GEMS, and GEMS is groupings, exponents, multiplication, division, left to right, subtraction, addition, left to right. So I want you to copy these two down, and then you're going to discuss this with your partner. How are you going to simplify this? What will you do first and why? What will come next and why? So take 3 minutes and work both of these out, and then we're going to check back in and see if your order of operations matches my order of operations. Okay? So pause the video here and begin. Okay, well, we're back. So I'm looking at the first example, and I'm looking at gems and groupings. Well, groupings include parentheses, so that means I have to do parentheses first. 35 plus 7 is going to be 42. And I bring everything else down. 42 divided by 6. 42 divided by 6 is 7. And I have simplified. There's nothing else that I can do. I've worked it out to my final answer. Now, looking at the second one, again, I'm looking at groupings, and I do have parentheses. So I'm going to add 4 plus 2, and that's going to be 6. And now I'm looking at, well, I don't have any exponents, so I'm going to look at, I've got multiplication, I have addition, and I have subtraction. I'm going to bring everything else down. And I'm going to look at 6 times 5. 6 times 5 is 30. I'm going to bring the rest of my information down before deciding what I'm going to do next. If you don't do that, that's where you can run into mistakes. So I don't have any division. I have addition and subtraction, but it's left to right. So I'm not going to look at subtracting first. I'm going to look at addition and subtraction are both the same level. So I'm going to go left to right. 30 plus 8 is 38. Then I'm going to bring down, subtract 2. 38 subtract 2 is 36. And I have simplified as much as I can. So again, remember when you're doing order of operations, you look for, do you have any groupings? Do you have any parentheses, brackets? Do you have anything that tells you what you need to do first with numbers? And once you've cleared any groupings, then you look at exponents, nope, no exponents, multiplication, division, and then subtraction and addition. Okay, good job. We've done a lot of work over the last few weeks with translating, and you have 3 statements here. I want you to, you don't have to write the statement down. I want you to write the translation. So for the first one, the sum of 15 and 8 minus the product of 2 and 7. The second one, the difference of 18 and 7 added to the product of 6 and 4. And the last one, the sum of the product of 2 and 4 and the product of 12 and 7. So take about 4 minutes for these. Remember, you're not writing the sentence down. You are writing your algebraic translation. So pause the video here, translate these 3, and then we'll check back in. Okay, so let's see how you did with the translations. The sum means I'm going to be adding, and I want the sum of 15 and 8. So I have the sum of 15 and 8. And that's going to be minus the product of 2 and 7. Product means I'm going to be multiplying. Product of 2 and 7. So I have the sum of 15 and 8 minus the product of 2 and 7. And I put these both in parentheses because I want to make sure that this is going to be the number that I have here, and that this addition is done first, and that this multiplication is then also going to be the number that I have here. And these are the two amounts that I'm going to be subtracting. So now I have the difference of 18 and 7. Well, difference means I'm going to be subtracting. Added to the product of 6 and 4. So I have the difference of 18 and 7. Added to the product of 6 and 4. So again, I have the difference, and I have this in parentheses to show that it's this term here that I am translating, and that's going to be added to the product of 6 and 7. And the last one that I have is the sum of the product of 2 and 4 and the product of 12 and 7. Well, I'm going to think about this now because this sounds a little different. I'm looking for the sum of, and I've got two products. So if I'm translating this, I'm not adding these numbers together because these I need to multiply. So I'm going to have 2 times 4 plus 12 times 7. And again, I'm putting these in parentheses to show that this is this translation here and this translation here. And I want the sum of those two products. So I'm going to be adding those together. Nice. Okay, this last one. Adding the following fractions and mixed numbers. I want you to copy down these mixed numbers and fractions, and I got you started by adding the whole numbers. But I'm noticing that I do not have common denominators. So you need to find the least common multiple, make equivalent fractions, add the fractional amounts, and then add that to your whole number. So let's take about 4 to 5 minutes for this one. And we'll check back in after about 4 minutes. And if you need a little bit more time, we'll give you a little bit more. Okay, so pause the video here and we'll check back in 4 minutes. If you need a little bit more, we'll add another minute. Okay, so pause the video and begin finding least common multiple and making equivalent fractions. See you soon. Okay, so I'm looking at the denominators of 3, 6, 3, 2, and 4. And the first multiple that all of these denominators would share is 12. Hopefully that's what you found also. Okay, 3 times 4 is 12, 6 times 2 is 12. And we've got reverses, 4 times 3, same thing as 3 times 4. But 12 is going to be a common denominator. So once you've found that, then you needed to make your equivalent fractions. And hopefully your equivalent fractions look like these. And some of you may have looked at that and said, That's an improper fraction. Yes, it is. But it was written as an improper fraction. So we're going to keep it that way. Okay? And 4 times 3 is 12. 1 times 3 is 3. 2 times 6 is 12. 1 times 6 is 6. 3 times 4 is 12. 4 times 2 is 8. 6 times 2 is 12. 7 times 2 is 14. 3 times 4 is 12. 1 times 4 is 4. They're your equivalent fractions. When you add them all up, you get 35 twelfths. 35 twelfths is definitely an improper fraction. When you write that as a mixed number, you have 2 and 11 twelfths. But you need to remember to include your 5. And your final answer is 5 and 11 twelfths. Good deal. Hopefully that's what you also had as your answer. I have every confidence that that's exactly what you got. And if there is still time in class right now, there is no homework for tonight. There is no problem of the week for this week. So you can either earn extra credit by creating some more fractions with unlike denominators and either adding or subtracting them, or you can read silently. But this is not social talking time. Okay, you have a few more minutes left in the period. So either work on some extra credit or read silently. And I will see you tomorrow.